Hey guys, can you hear me?
Yeah.
I can hear you.
Okay, cool. All right, guys, let me share my screen. All right. All right, guys, we'll again get started with your questions.
Yeah. Can we do a couple on balancing? I'm not sure if the key is right or not
Where?
on the balancing acidic at basic solutions because
Uh,
I keep on getting a few things a little bit off in the key.
yeah, let's see. There are one or two typos in there. So balancing redox equation.
Mm-hmm. Number 11. I don't know if I'm doing it right or wrong
Number
because I
11.
kept on getting the electrons on the same side. I know that's incorrect.
So number 11.
Yeah.
Okay, so what are you getting?
I kept on getting the number of electrons on the same side, and that's not right. So I don't know what I'm doing wrong.
So all right, so this is the equation.
Right. Yep.
All right, so let's see. So you have, oops. This is not right. All right, so you have TE going to TeO3 negative 2.
Mm-hmm.
And then you have NO3 negative going to N2O4.
Yes.
All right, so what did you do for this left one, TE?
For TE, what I did was I added 3 waters to the left side, right?
Right, and then
And then after that, I added 6 hydrogens to the right side.
6H plus, you mean?
Yeah, 6 H pluses. Yep.
And then
And then you have four charges after that, correct? Because there's a negative
plus
2
4, right?
plus 4. So
And
then
this
I need to
side
put.
is 0.
I'm sorry.
Yeah, the left hand side is 0, and then the right hand side is plus 4.
So I need to put 4 electrons on the right side.
Right, so you'll just add 4 electrons here, right? Because it's
But then when I got to NO3
right,
minus
right.
and N2O4, I got 8 electrons on the same side, and I know
Let's do
that's
this one.
not
So what
right.
did you do for this half?
This half, I added 1 water to the left side.
Did you balance the nitrogen?
Yeah, I put two. I put a 2 in front of the nitrogen.
Right. And then what did you do for oxygen?
I added 1 water.
Where? Not 1 water. So
Uh,
if you put 2 here, you got 6 oxygens, right?
right,
And here you have 4 oxygens.
right.
So how many water should I add on this side?
2.
2 waters, right?
Mm-hmm.
Did you do that?
No, I think that's what
Yeah.
I probably was
Yeah.
doing wrong.
So that's what you gotta fix.
Okay. And
Okay.
then now I add 4 H pluses to the left side, right?
Right. So you're gonna add 4H plus on this side. Yeah. And then you gotta check your charge. Your charge here, this is plus 4, and this is negative 1, but there are 2 of them, so negative 2.
Yeah,
This is
so we
negative
need
2,
to
this is
add
4,
two
so this is
electrons to the left side, right?
right. So this side is 0, this side is plus 2, so you gotta add 2 electrons on this side. Now you can see the electrons here are on the left hand side, here they're on the right hand side. So that
Right. I think that's what I was doing wrong.
right.
So I'm on, like, for a reason I don't get confused on the amount of waters I need to add. What do you recommend I looking at, like the oxygens on the left side, or what should I do? So, because that's where I got stuck on that part.
Yeah, exactly. But I think you didn't put a 2. Did you balance? I think you maybe you forgot to balance the nitrogen. Did you balance nitrogen by putting 2 here?
Yeah.
Then did
We
you
did
multiply 2
actually.
times 3, 6? Did you do that for oxygen?
No,
You didn't do that.
honestly, that part I didn't do.
Right, right. So that's where you have to. So whenever you see, like you caught that your electrons are in the same site, so go back and carefully check each step. Look
Yeah,
for the.
because I know you can't have your electrons on the same side because
Right,
that's wrong.
right,
Okay. Now in this case, I can multiply. We want the electrons to be the same,
right.
so I multiply two to the two electron to the
Yeah,
one
this
with the
whole
two
site is
electrons,
multiplied by 2.
because I can leave the top one alone. That'll give me the same amount of electrons.
What do you mean by top one? The left one?
Yeah, I can
Yeah,
leave the left one
right. That
alone. I
one
mean, I'm, I
stays
mean, I'm
as
not
it
saying
is.
we're done, but
Right. And here, this one you got to multiply by 2 to
right,
make it 4 electrons, so that it matches with the 4 electrons on the left hand side.
right,
Right.
all right.
Okay. Does anyone else have question on redox? Is anyone else having hard time with the redox?
Anybody else here?
No.
No.
All right. If anyone else have question on this, then we can like finish this problem. If not, then we'll pick something else. All right. I guess tell me if you guys have anything else. Nick, does that answer your question? The rest you can do, right?
Yeah, the rest I can handle from now.
Okay, cool. All right, guys. Ask me some more questions.
I have a question from the gas laws worksheet, the exam worksheet that you gave us.
Gas laws
Some
stoichiometry?
question. Yeah, I have a few questions.
Sure. What question number?
So I have a question on number 14.
Number 14. Okay.
So I got stuck. Let me see. So I got the amount of moles for
From 3.5 grams.
yeah.
You got the moles, but how did you get the moles? We don't even know what gas that is, right?
Yeah, exactly.
So first find the moles, and then use the mass that is given to you to find the molar mass. See, the question is saying find the molar mass, right?
Mm-hmm.
And we are given mass.
Yeah.
So, and we are given, of course, what is this? This is volume.
Yeah, volume and
This is
then
temperature. This is
pressure.
pressure. So of course we know we got to use PV is equal to nRT, right?
Mm-hmm.
And then I can find N from here. N is going to be equal to PV over RT, right?
Mm-hmm.
And then I can put the P, and then I can put V, I can put T, I can put R, and that will give me moles, right?
Mm-hmm.
Once I have the moles and I have the mass, I can find molar mass.
So I got the moles equaled 0.085832. It was a long number.
That should be good. Yeah, that should be good enough. So
And then
you
you just divide that by 3.5.
So let's see. Let's see if we need to divide or multiply. We'll look into the formula. Okay. So there are two ways you can approach this. One is actually very simple. You see this? The molar mass, the molar weight of gas is dash grams per mole.
Mm-hmm.
You see what are the units?
Grams per mole.
So who are the grams? 3.5 grams. So put that here. 3.5 divided by the moles.
Okay.
That's one very simple way. But in case you're not given that and you don't remember what are the units for molar mass, then do it this way. You remember that moles is equal to mass over molar mass?
Mass over molar mass?
Yes. Now, see, we have never seen it. I mean, we have once in a class when I was talking about this, we did talk about moles as mass over molar mass. But do you remember how do you change mass to moles? You always divide it by the molar mass.
Yeah.
Get the moles. So this is just that formula. Moles is equal to mass over molar mass. What am I trying to find? Molar mass, right?
Mm-hmm.
So I can take the molar mass up there. So molar mass will be equal to mass divided by moles, right?
Yeah.
Right. So now that's the formula. So you can take the mass, which is 3.5 grams,
Mm-hmm.
and divided by the moles that you got 0.08583 moles. And when you divide this, you should get the answer. And I think the answer says 41. If you divide
41.
that, you get 41. You get 41.
Um,
Let's see. So 3.5 divided by 0.08583. Yeah, that's around 41. That rounds up to 41.
okay.
So the answer is 40.778. And that will round off. Based on 2 sig figs, you see there's only 2 sig fig in the question. So
Yeah.
based on that, this would be 41.
Okay.
You can do this also in the PV equals nRT formula, right?
Yeah, that's what we did. PV equals nRT.
To get the moles, and then
Right.
we
To
use the
get the
moles
moles,
to get the
and
molar
then
mass.
from moles, we figure out the molar mass.
Okay.
You divided the 3.5 and the moles, right? And that just gave
Right.
you your
and
answer
moles.
rounded up.
Right, because this is the formula. Moles is mass over molar mass. We shuffle this equation to isolate molar mass. So molar mass is equal to mass over moles.
Yeah.
Or you can just see that from the unit here. You see grams over mole, mass over mole. That's the unit for finding molar mass. Mass over moles. So we can simply just
Yeah. Definitely. No, thank you. That makes a lot of sense now.
Cool. Put in a chat or something. The student is asking, will Celsius, Fahrenheit be, yes, you will be provided a conversion for temperature in case you need to change Celsius to Fahrenheit, Fahrenheit to Celsius. You will be given that conversion. Asking more questions?
What about number 22 on the other worksheet handouts?
Number 22, you said?
Yeah, it's the one, I think it's the second method.
The thermochemistry?
Yeah.
Thermochemistry. Number 22, right?
Yes.
What's wrong with my word?
That was the one we did last time. Could we do number 23? Because we did number 22 on Friday.
Something wrong with my word. Just give me a second, okay? Number 23?
Yeah.
This one. Okay. So yeah, so you're given reaction, 2 reactions, and then you have to find the delta for this reaction. So you gotta match your top 2 reactions with the reaction that we want to find for. So did you give it a try, or
What was that?
did you give it a try? Do you have any specific question on that, or you just want to
I
organize
just don't know, because I know you have to put like a number in front of one of the equations to get the bottom equation. I just don't know how to pick that number to match it up to the equation you want to get close to.
Oh, okay. So let's see. So see, this is the equation that we're interested in, right?
Yes.
So we want to make these 2 reactions look like this one.
Mm-hmm.
So you see, this reaction has N2O2 and NO2.
Yes.
So here you have NO. We're not going to worry about that because it's not even in our reaction.
Okay.
So then you're going to look at N2, all right? So you see N2, that's common in our reaction.
Yes.
N2. So now you gotta see this N2 is on the right-hand side, but in my main reaction, this is the reaction that I'm interested in. In this reaction, it's on the left-hand side. So this is the reaction that you have to play with, okay? Not this one, this one. So what we gotta do is, see this nitrogen on the right-hand side of the arrow, here it's on the left-hand side. That means we need to flip this equation.
Okay.
Okay, by flipping, what do we mean? We want to write the things on the right-hand side on the left-hand side, and what the ones are on the left-hand side, we're going to write them on the right-hand side of the arrow. So I'm going to write instead N2 plus O2 gives me 2NO. And you remember what will happen to the delta H when you change the flip the equation?
Change the sign.
Yeah, you switch the sign. So delta H for this new reaction is positive 180 instead. Positive 180. Okay.
So the sign switched because you switched the.
Because we switched the reaction, the direction of the reaction.
Hey, Amon, quick question.
Yeah.
Do you change the reactions like the 2 and O on that problem because you want those to cancel out or no?
No, don't even touch the one. You see, this is 2NO, this is also 2NO, so they will eventually cancel out. But
Right.
don't think that
Right.
you'll probably not need that, okay?
Right. But don't you have to basically change them in a way or no?
No,
In this case?
you don't. No. So let's see. The ones that we are interested in only look at that molecule. You see, right now, my focus is on N2 and N2.
Right.
Just worry about N2. They're both 1 and 1, so I'm not going to do anything.
Oh, so you're just basically trying to equal what the bottom formula is, right?
No, I'm looking at here. You see, this is 1 N2.
Yeah,
This
exactly.
is 1 N2.
Yeah, you're trying to get the N2 plus 2O2 into 2NO2, right? That's what you're trying to look. That's what you're looking at to get, right?
So, but don't look at the whole reaction. I'm just looking at molecule, just one molecule right now.
You're just looking at the N2 first. That's what
Right.
you're trying to get first. Okay.
Yeah. Don't look at the whole reaction to begin with.
Okay.
Look at this reaction, match it to compare it to this reaction. You first figured out NO was not even in your reaction, so don't worry about that. Skip that one. Go to N2.
Right. Okay.
N2, there's just one N2, and there's one N2 here. That's good. So we don't need to multiply or anything, but we need to see here that N2 here is on the right-hand side of the arrow. Here it's on the left-hand side of the arrow. So I need to flip this reaction. That's why we wrote it by flipping it. I did not touch the numbers. Right?
Okay. Right.
Okay. All right. So now next thing. Brianna, is that making sense to you so far? Yeah. Okay. So and then we got oxygen here. And then you see the next reaction also has oxygen. Again, don't also look for the ones which are common in both the reactions. Look for the one which are unique.
Okay.
Like you see N2 was here, but not in this reaction.
Okay.
And then if we look at the next one, let's say again, we look at this reaction, NO, it's not here, so we're not going to look at that. Oxygen again was in both of them, so you can skip that one also. Look for a unique one, like you see NO2. NO2 is not in that top reaction, it's only in this reaction, and it is there in the reaction we're interested in. Is that good, Brianna?
Yeah.
Okay, so we got NO2 and NO2. They are both on the right-hand side. That's a good news. They're both 2 and 2, so that's also good news. If it was not, let's say this was just 1 NO2, and in our reaction there was 2 NO2, I'll have to multiply this whole equation by 2 in that case, if it was not 2.
Okay.
Is that making sense, or is that too much?
Yeah, it does.
That makes sense. Okay. All right. So in this case, it's perfectly all right. So the reaction is 2NO. So I'm just going to write this again. So 2NO plus O2 gives me 2NO2. And this reaction, we're going to keep it as it is because there's no need to change anything. So delta H for this one is negative 112, right? Now what we're going to do is we're going to add these two reactions and see if we can actually get the reaction that we're interested in. We always want to confirm that, okay? So N2 plus O2, I'm just rewriting both the equations. I'm going to add the left-hand side to the left-hand side, and then I'm going to add the right-hand side to the right-hand side.
Like we do in redox
Right,
equation.
exactly. Like the way we, in redox reactions, we combine the reactions by adding left to the left and right to the right. Exact same thing.
Okay.
And the next step is also going to be exact same. We're going to cancel things that are common. Plus 2NO. So you see N2O2, and then I'm going to 2NO again O2. Right?
Mm-hmm.
This gives me 2NO plus 2NO2. So what you see here is this is O2 and O2. We can combine that to 2 oxygen. So if I want to, let's say first things that we can cancel. Do you see anything that can be canceled?
The two NOs.
Yeah.
2 NOs can be canceled. And then you see this O2, O2 can be combined. So I'm just going to rewrite the equation. O2 plus O2 is 2O2, right?
Mm-hmm.
And this is giving me 2NO2. Does that match? Does this match with the reaction that we are interested in?
Yeah.
Yes, it does, right?
Why? How come you didn't cancel the O2s out? How come you combined them instead?
They're on the same side, right?
Right.
If they're on the opposite side, you cancel. You see the arrow sign here?
Right.
If the things are on the opposite sides of the arrow, you cancel them.
Okay, that makes
If
sense.
they're on the same side, you are adding them, right?
Okay. I just wanted to ask that because I don't want to go on the test and make that mistake.
Sure. So we got this reaction, right? See,
Right.
now we can see that by adding these two equations, we get the equation that we're interested in. Hence, the delta H for these two reactions should also add to give us the delta H for this reaction. That makes sense?
Yeah.
What we need to do is we need to just add the numbers. So 180 plus negative 112. And of course, if you're going to do the math, this is plus 180 plus minus is minus 112. So the answer will be positive
68.
68. And answer is indeed A, which is 68.
Okay.
Huh?
That makes sense.
All right. And then also remember, you could be asked a question in addition here, like, is this reaction exothermic or endothermic?
Mm-hmm.
What do you think? Is this endo or exo? You see the positive sign here?
Yeah.
Positive sign tells me this reaction is endothermic.
Okay.
There's something wrong with my pen. So this is endothermic reaction. And now you could be again asked additional question here. And that additional question could be, you see that this reaction is plus 68 kilojoules
Mm-hmm.
for how many moles of N2? Do you see that there's number 1 here, which we don't see, but there's a 1 here?
Mm-hmm.
Right.
That's for 1 moles. And
Okay.
this 68 kilojoules is for how many moles of oxygen?
2.
2 moles. And for how many moles of NO2?
2.
Does that make sense to everyone?
Yeah.
Yeah.
Because you'll see
Yeah.
a question connected to this. If you see your study guide, which I did in class, you will see that I mentioned that this question is going to be combined with 2 questions, like
Okay.
endothermic, exothermic, or like what I'm saying right now. So basically, what I'm saying is that this 68 kilojoules belongs to 1 mole of N2, 2 moles of O2, and 2 moles of NO2, right?
Right.
Right.
So what we can say here, I could ask you a question is, okay, if I have 24.5 grams of oxygen, then delta H is going to be how much? Do you see that? Do you see what the question is?
Mm-hmm.
So basically it's saying, okay, so if we see for oxygen, the question is for oxygen, right? So we can say here, we know that this 68 kilojoules is for how many moles of O2?
1
No,
or 2. 2.
2 moles, right? Because it says here the 68 kilojoules
Mm-hmm.
belongs to 2 moles of O2, right?
Mm-hmm.
So this is our conversion factor. Right? So think about that. And you are given that we have 24.5 grams of oxygen. Again, just to remind you guys, not the part, I mean, this question is already done, right? We got the answer. But what I'm telling you is you can have these extra questions on the test. Okay. So we got this, that for 2 moles it's 68 kilojoules. So for 24.5 grams, how much is it going to be? Do you guys have any idea how to solve this question?
So you take the grams to moles, the grams of O2 to
Right,
moles.
right. So the question says we have how much? 24.5 grams.
Mm-hmm.
So we have, let me just use this more. I think
Macho
I'm better
teléfono.
rate on this. 24.5 grams of oxygen. We're trying to find the delta H. And then we are given that it's 68 kilojoules for every 2 moles of oxygen. First of all, guys, does this part make sense to everyone?
Not really to me.
So yeah, you should be asking me then if it's not making sense.
Yeah, I was about to ask you right now on that.
So you can see that when we solved this whole thing, we figured out that for this reaction, 68 kilojoules is the answer for the reaction. So that 68 kilojoules
Right.
belongs to 2 moles of oxygen, okay?
Mhm.
That's where we're getting this from. 8 kilojoules for every 2 moles. Okay. So what we're going to do is, of course, we want to find it for 24.5 grams of oxygen.
Right.
So we want to change this to from grams of oxygen to moles of oxygen. This we have done many times. How you change grams to moles. And then, of course, down here is moles of oxygen. And we are trying to find kilojoules because the question said, what is the delta H? And we know delta H is in kilojoules, right? So 1 mole of oxygen is how many grams of oxygen, guys?
You're looking for grams of O2, right?
Right. What is the molar mass of oxygen?
Is it 16.0 or 15.99?
Yeah, that's for 1 O, right? So for 2 of them, it's 32.00,
Right.
right? And then for moles to kilojoules, we know that every 2 moles is 68 kilojoules.
Correct.
Now you can solve this whole thing.
Okay. Now we just do the correlation to that. Let me get my calculator.
So what you get is 26.03125 kilojoules. Does that make sense, guys?
Yeah.
Yeah. So that might be our free response question, or
Right, so guys, the question is, where did we get this 24.5 from? So I just made up the question, okay? I just made up the question that if we had 24.5 grams of oxygen, what will be the delta H? So this is the part of question. This is a question. Okay, so we were, as I was saying earlier, we were done with this question already. So there's all of this.
like we were done, but you were just giving us an example depending on the exam, right? Because you said the exam there's going to be a question like this, but you're
Right,
going to want us to know the moles and stuff, right?
right, right. So we already got the answer, and the answer was, wait. And we got the answer, and our answer was 68 kilojoules, and we we're done here. But what I was saying is, in case the question extends and says that we have 24.5 grams of oxygen, then what is the delta H for that going to be? For that, you need to do all these steps that I did
Okay.
here. We went from grams to moles and moles to kilojoules. And the moles to kilojoule conversion comes from this equation, that 68 kilojoules belongs to 2 moles of oxygen. That's where this is coming from. So this is coming from your reaction delta H. Okay. Very good. Questions? Any more questions out here?
I got a question on the same worksheet.
Okay.
Did we do 34 in the workshop, Ahmad, or which one did we do?
I think yes, we did 34.
Can we do 35? Because that one is, oh my god, that one's having me a little bit thrown off. Because I was looking at 34, but I still wasn't really sure what I was doing for that problem.
Where did that computer? So you guys were saying number. Somebody said what number?
35?
35? So you guys want to do 35?
Yeah.
If they want to do 30, if they want to do 34 too, that'd be nice too. Or if
We
you want
did
to go over that.
34 in our workshop. 35 is very similar. What this is saying is we have volume molarity for HNO3, volume molarity for NH3, again placed in a coffee cup calorimeter, which has a heat capacity of 30.3 joules per gram per Celsius. You're given density, you're given specific heat of the solution, original temperature, final temperature. You have to again find the heat for the reaction. I think we did this question in the class. So can you copy the question?
Trying to make sure I understand this before I take the quiz, because I'm sure this will be on the quiz today.
All right, so this is the reaction given to us. NH3 plus HNO3 gives us NH4 NO3. That's a reaction. And then we are given a few things. Let's see what we are given, okay? We are told that we have a 50 ml. This is not very good. Give me a second. So we have 50 mLs of HNO3, which is 1 molar. And then we're also given that we have 50 mLs of NH3, which is also 1 molar. And they're placed in a coffee cup calorimeter, which has a heat capacity. You're given a cup heat capacity. So for a cup, you're given that its heat capacity, so capital H, is 30.3 joules per Celsius. And then you're also given that the density for solution, the density is 1 gram per ml. And we're given the the specific heat capacity, which we show as small c or s, whichever way you like it, 4.2 joules per gram degree Celsius. And then you have the original temperature. So your initial temperature, which means is 23.7 degrees Celsius. And we're also given that the final temperature is 24 degrees Celsius. Right? You have to find the heat of the reaction. So you want to find the Q reaction. That's what they're looking for. And they're also looking for Q reaction. You see here it says determine the heat released in the reaction. That's Q reaction. That's what we're looking for, one thing. Second thing, how much heat is released per mole of ammonium nitrate. So Q reaction per mole of ammonium nitrate, NH4NO3. So if you guys remember, Q reaction over moles is actually delta H reaction. So basically the question is looking for delta H reaction. It's just not using that word, but it's giving you the units. What is given to us, does that make sense, guys?
Yeah.
All right. So if we see, we want to find delta H reaction, which is equal to Q reaction over moles of NH4NO3 in this case. How do you find Q reaction? Because if you want to find this is the first reaction that we need. I mean, the first equation. But in order to do that, what do we need, guys? We need Q reaction. What is Q reaction equal to?
Is it Q reaction or heat?
What is
capacity times change in temperature.
That's the Q for solution, remember? Or for the coffee cup. So what is
Q product
reaction?
minus Q reactant?
No,
Oh.
this is not that question. Q reaction is equal to negative Q solution, remember that?
Oh yeah.
But this question, you see, is also talking about the coffee cup. It's giving us the heat capacity of the coffee cup. for this, you guys remember that we actually need to add the Q solution and the Q cup.
Yeah.
This is the same problem we did also in the lecture, and then we also did this in the worksheet. I mean, the workshop on Friday. That reminds us that Q reaction is equal to wherever the heat is being given off. In this question, the heat is being given off to the solution and to the cup. That makes sense, guys?
Mm-hmm.
Right.
Now,
So-
now there is a possibility that you're going to see a question on your quiz, on your test, where it does not talk about the cup. If it does not, then just forget about the cup. Then your Q reaction is just equal to a negative Q solution. That's it.
Now, if it was for cup, it'd be like the one like you did on number 34, right? In the
Yeah.
workshop.
34, 35 are basically the same questions. Okay. So for this question, this is what you got to do. Q reaction is negative Q solution and Q cup. All right. Okay. So there's somebody who has some noise from the back. Can you guys mute yourself?
Think.
Did this app change or something? Because now I can actually see the people we're talking to and stuff.
No, you guys made yourself visible. That's why. You just gotta stop your video. If you stop your video, then you won't see. Yeah. Right. So, are we good here, guys? Here so far?
Mm-hmm.
The delta reaction is Q reaction over moles of the reactant or the product, and then Q reaction. This is the Q reaction. We want to find this Q reaction first. This Q reaction is equal to negative Q solution plus Q cup. In this case, we're including cup because the question gives us some information about the cup, so we got to use it. Otherwise, you may see a question which is just this: Q reaction is Q solution. And then you got your third step because you want to find Q solution and Q cup, right?
Right.
Q solution and Q cup. What are they equal to, guys? They're the one where you use MC delta T. Here for a Q cup, are you given the mass of the cup, guys? This is what you're given for the cup, right?
Yeah. We're not given the mass yet, are we?
You're not given the mass. You're given heat capacity. When you're given heat capacity, you don't even need mass. Because if you remember, the Q cup is going to be equal to the heat capacity times delta T. That's it. This formula does not even need mass. So guys, do you remember that there were two formulas for Q?
Mm-hmm.
Yeah.
There's MC delta T. That's one formula, which
then
has
there's
mass and specific capacity and delta T.
And then there's CDT, right?
And then there's H
H times delta T.
times delta T. This is heat capacity.
Okay.
On
it's
the
like
other hand,
hot.
this C is specific heat capacity.
On the way you can remember also ACT, can't you also say like hot or something like that too? Or what do you recommend?
I mean, yeah, you can if you want. And the mass is, of course, M is, of course, the mass. Okay. So these are two formulas for Q. You got to use whichever one you think is more suitable based on the given information. In this question, we got to use both of them. For solution, we're going to use MC delta T because we're given, you see in the question, we're given the C for solution. This is C. For solution, we're given these two things. The question says that clearly. It says the density of each solution is 1 gram per ml and specific heat of solution is 4.2 joules per gram Celsius. So this is D and C, density and C for the solution. So now let's go back to our third part, which is these two equations. So what we're going to do is we're going to plug in the numbers here. We're going to plug in the numbers here. We're going to put them then inside here. That will give us the Q reaction. Once we have the Q reaction, we can find the delta H reaction. Does all that make sense, guys?
Yeah.
Yeah, a little bit.
Okay. Right. So I'm quickly going to show you what a Q solution is going to be. Q solution is MC delta T. What is the mass of solution, guys? Are we
100.
given in the question? Not directly, but you're given
The
volume.
density.
100 millimeters.
Right. You're given volume and density. So total volume for solution is how much, guys?
100 milliliters.
Volume is 100 milliliters. What is the density?
1.0 grams over milliliters.
So what is the mass going to be?
100 grams.
Grams.
So this will be 100 ml. Oh, not I mean, not to confuse
Grams,
you.
right?
Not to confuse you guys here. So density is 1 gram per ml times 100 ml. So I'm just showing you the work just in case density is different on the test. You should know how to use this.
Okay. But the milliliters cancel out, right? Come on.
Right. So that's why you got 100 grams. So we know the mass of solution is 100 grams. We have a question here.
Yeah, he's saying that he'll be looking forward to seeing the rest of it on YouTube. That's what that person says.
Yeah.
You
Right,
won't have it
so-
on there, right?
Yeah, I'll be uploading that. Yeah. So we got the mass 100 grams, and then we got the C. What is the specific capacity for solution? 4.2 joules gram Celsius.
Mm-hmm.
And then we got the delta T. What is the delta T for our solution? What's 24.8 minus 23.7? That's 1.1 degrees Celsius, right? So you're gonna put that here, 1.1 degrees Celsius. So guys, when you plug that into calculator, what do you get? You get 462.
462. Yeah.
462 joules, right? That's my Q solution. What is the Q cup gonna be, guys? Q cup is heat capacity of the cup times delta T.
Mm-hmm.
Delta T is still 1.1 degrees Celsius. What is the H4 cup?
It's given, right?
It was how much? 30.3?
Yeah.
It's 30.3 joules per Celsius. Celsius gone. What is 30.3 times 1.1?
33.33.
33 joules, right? So this is my Q for cup. This is the Q for solution, right? So what is your Q reaction going to be, guys? Q reaction is negative Q solution plus Q cup, right? Remember that?
Yeah.
So what is Q solution? 462 joules. Q cup is 33.33 joules. So guys, when you add that together, what do you get?
It's 495.33.
So your answer is negative 495.33 joules. This is the Q reaction, right?
Right.
So you see, this is the first answer. The question says, I remember, it's looking for these two things, Q reaction and Q reaction over moles of NH4NO3.
Mm-hmm.
Right.
So we got the Q reaction, negative 495.33. That's our first answer. Then the question says, also find the Q reaction over the moles of NH4NO3. Our Q reaction, of course, is negative 495.33 joules. What is our mole for NH4NO3? Mole for NH4NO3, guys. You see what?
What?
Moles of NH4NO3.
Is that the 5 right there, or the?
Well, it's not given, but we're given the molarity of NH3, right? So
Right.
we should be able to find it from that.
Right. So we are given that we have 50 mLs of 1 molar HNO3. Can you tell me that's how many moles of HNO3?
1. Oh, so it's 1 mole of
molar.
NH4.
And we have only 50 mLs.
Mm-hmm.
How do you find moles from molarity and volume? Molarity is moles per liter.
Yeah.
Erase all of this, okay? Just so that we have more space here.
So molarity times volume equals moles.
Right. So molarity is moles per liter. So my moles are gonna be molarity times liter. For both of them, do you see actually numbers are the same? 50 and 1, 50 and 1. So molarity is 1 molar and volume is 0.05 liters.
Mm-hmm.
So my answer is 0.05 moles. So I have 0.05 moles of HNO3 and I have 0.05 moles of NH3. So how many moles of NH4 and NO3 am I going to make? You guys remember stoichiometry?
Is it just going to be 0.1?
No, you don't add them, right?
Oh, you don't add them.
Remember in a mole to mole ratio?
Oh, it's 1-to-1, so it's just
1 to
going to
1.
be
So
0.05.
0.05 moles of NH3. Let's just pick one of them, right? Because the calculations are the same.
Mm-hmm.
So moles of NH3. This is moles of NH3. We are trying to go to moles of. Right. I guess you gotta mute yourself. We can hear you. So moles of NH3 to the moles of NH4NO3, that's 1-to-1 ratio. You guys are. Can I mute you guys?
I don't know. You should be able to if you're the host, right?
Yeah, but I don't know where this noise coming from. Yep, because all of you guys are here. Is that good? I think that's good, right? No?
Yeah.
Okay.
Yeah, I think that was it.
Okay. All right. So 1-1 ratio. So we got 0.05 moles of our product is NH4 and 3. That's what we were looking for.
Mm-hmm.
So 0.05. No, so I think I meet somebody else. Okay. All right. So what we were looking for is, if you guys remember at the end, we were looking for this 2 reaction over moles of NH4 and 3, and we figured out that it's 0.05 moles. So if we divide these two numbers, we should get our final answer. So we have 495.33 divided by 0.05. This gives us, of course, negative 9906.6 joules per mole. Okay. Now, in case the question asks you to change this to kilojoules, you can change it to kilojoules. Just divide it by 1,000. This will become negative 9.906 in that case. But otherwise, this should be good. Right?
I have a question on the same worksheet, if that's okay.
Sure. But guys, I know this was a long question, but you gotta make sure you understand this. You are saying this on your exam, okay? I guess. Questions for me?
Can we do number 10 on the same
Right.
worksheet?
Number 10.
Or did you mean on this question? Sorry.
I don't see anyone asking me anything for that question. Number 10. Okay. So you see this question is like the question that we did earlier when I added a question by myself. Doing that question number, I think 22 or 23. So let's see this question. So it says hydrogen gas. Let me copy this question. Okay.
Okay.
Right. So we are given that hydrogen gas. So we should will write the equation here. Hydrogen gas, H2.
H2 plus Br.
Br2, bromine gas.
That's your BR2.
reacts to form hydrogen bromide gas, which is HBr. How much kilojoules, how much heat is released when I have 155 grams of 155 grams of HBr is formed, and you're given that the delta H for reaction is negative 72 kilojoules. First thing first, we gotta balance this equation. And you can balance this by just putting simply a 2 here in the front.
Mm-hmm.
So now this is balanced. We're given that the delta H for this reaction is negative 72 kilojoules. We want to find this for 155 grams of HBr, right? This is what we're looking for.
Yes.
The delta H for 155 grams, or kilojoules for 155 grams. So what you're given is that delta H reaction is negative 72 kilojoules. Now, can you tell me that's for how many moles of HBr?
2.
Exactly, for 2 moles. Because see, this delta H is for the reaction, and the reaction has 2 moles, right?
Mm-hmm.
So this negative 72 kilojoules actually belongs to 2 moles of HBr.
Okay.
Once you're here, the rest is same as the previous question we did. So we're given that we want to find it for 155 grams of HBr. So of course we need to change grams to what?
Moles.
Grams of HBr to moles of HBr. And then from moles of HBr, where are you going to go?
To
To the kilojoules.
the mole. Oh, okay. The kilojoules.
The question says, you form this, how much heat, how much kilojoules
Okay.
is released from 155 grams, right? So
Yeah.
we're trying to find the kilojoules for 155 grams. So first we change grams to moles, and then we'll change moles to kilojoules.
And since we know that it's 2 moles for
Right,
that,
so it's 2 moles of
Okay.
HBr to negative 72 kilojoules. And then we gotta put numbers here, moles to grams. So 1 mole HBr is, you gotta find the molar mass of HBr. How much is the molar mass of HBr?
it's 1.008 plus. So it's 80 point. It's 81.008.
81.008.
I'm sorry. It's 80.908.
80. 80.908.
Yeah. So 80.908. Yeah.
Okay. So now, of course, you're just going to plug in numbers and multiply by 155 times 72 divided by 80.908 divided by 2.
Does it have to be times a negative 72 though? Right.
Now, when you're putting on calculator, you don't have to put a negative.
You just add the negative at the end.
Yeah, you just bring that negative at the end. Yeah. So that's what I'm seeing. Negative 68.967. That's the answer. Negative
Yeah.
69. There, we'll round it off to negative 69. Now, if you downloaded, I think the key earlier, maybe the answer said B. Did you guys notice that?
Yeah, mine says B.
Yeah, yours maybe says C. So download the most updated one.
Okay.
I changed it to C because somebody else brought this to me, and I saw this was a typo.
Oh, okay.
And I think there was one more, had a very similar typo. The negative positive thing. Maybe it was number 12. What does the number 12 say?
It says that the answer is C negative 12.
Yes, that's right. There was one more.
13.
So make sure you check your answers again.
Okay.
Okay.
Yeah, there was one more. Check number 5.
The 5 was exothermic release C.
Yeah, that's right. Yeah. Yeah, there was one. So make sure you download a new one just to confirm. Okay.
Okay.
All right. Does that answer your question, Steven?
Yeah, it does.
Does anyone else have any questions?
Can we do one on the same worksheet? It's number 28.
Number 28. All right. So number 28, you're given, right. So this is a third kind of question, right? So
Mhm.
if I can copy this. Let me see if I can just write here. Okay. So we're given that we have C right here now. Okay. So what we have is C2H5OH plus oxygen gives us this plus water. We're going to find the delta H for reaction. And then we're given all these different, we're given these for numbers for all these different molecules. Whenever you're given delta HF, you see this thing, delta HF? Whenever you're given this, we have to use the formula delta H reaction. Remember, what is that equal to? Delta HF
Products
products
minus reactants.
minus delta HF reactants. Okay. So product minus reactant. So we got to make, who are the products? These two guys are products, right?
Mm-hmm.
Who are reactants? These two are reactants. So we
Mhm.
got to do these ones on the right hand side minus the ones on the left hand side. So first thing to notice here, you see all of these are 1 mole, 1 mole, 1 mole, and 1 mole. So here we don't need to worry about that, but on the test you might see where there are numbers. Like you see the next problem, 2CO, 1O2, and then 2CO2. In that case, you will have to actually multiply their, let me scroll this down. In that case, you will actually have to multiply these numbers with 2, like you see for CO2. It's negative 393.7. You have to times it by 2 when you plug it in. So
Okay.
just make sure you do that, okay? Right, so let me fit this right. Yeah, okay. So delta H of products, products are CH3CO2H, which is this guy right here. So negative, so you got negative 484.5. This is our first product plus the second product. The second product is H2O liquid, which is minus, so plus minus will become minus. So minus 285.8 minus outside for reactant. And for reactant, the numbers are C2H5OH. C2H5OH is negative 277.7 plus the delta HF for second, which is O2. And do you remember what is the delta HF for O2?
0.
0, right. So you're going to put a 0 here. So now you just got to solve for the whole thing. Okay. So negative 485, that's going to add, so 4.5 plus 285.8. Something wrong.
We did minus 285.8.
So, yeah, so it was plus minus, right? We added it,
Oh, okay.
but in parentheses it has a negative, right? It will become minus. So you should get here negative 770.3. Did you guys get that?
As the final answer? Oh, I see. Yeah, that's what I got.
Yeah. And then of course this is minus become plus. And then you're gonna of course subtract these two numbers. So you get at the end negative 492.6. That should be your final answer. And that's the answer D, 492.6, negative 492.6.
Yeah.
So we don't do nothing with the 52.3 since it's not up there, right?
Yeah, see, that question is just giving you that number randomly. but you actually don't need it. Because it's maybe trying to see that, okay, there's oxygen there. People are going to think where the oxygen is, and they're for some reason going to add that number, or maybe just not carefully see them and mix match the other reactants or products with C2H4. It's just there to confuse you. So you got to be careful that you don't need that.
Oh, okay.
Okay. Okay, so it's already 1. I'm going to stop the video here, and then I'm going to upload this on YouTube, so in case you guys want to watch this again. And then make sure you guys bring questions either in the office hours or bring them in the lab. Okay.
One more question. The left-hand side of the arrow is products or reactants?
The left hand side, these when I have to say this in a sentence, okay, what I
Okay.
say is C2H5OH and oxygen react with each other to produce CH3CO2H and H2O. So
Okay.
understanding this, you'll never forget that these two things are reacting, right? So they're reactant.
Mm-hmm.
And you see the arrow? That tells me that we're producing these two. So these two are products.
Oh, okay then.
Okay. All right, guys.
All right, thank you.
All
Thank
right,
you.
cheers. All right. Any general questions about the quiz, about the exam?
No.
Very
The
good.
quiz is due Monday, right?
Yes, it's due Monday, before Monday
Okay.
lecture.
Cool.
All right.
All right.
All right, cool, guys. See you guys in the class.
All right, thank you.
Bye.